So let's discuss half-life. We now turn to exponential decay. One of the common terms associated with exponential decay, as stated above, is half-life, the length of time it takes an exponentially decaying quantity to decrease to half its original amount. Every radioactive isotope has a half-life, and the process describing the exponential decay of an isotope is called radioactive decay. To find the half-life of a function describing exponential decay, we would solve the following equation. We would have the half of the original amount, which is equal to the original amount times e to the power of kt. We find that the half-life depends only on the constant k and not on the starting quantity a subscript 0. Now the formula is derived as follows. We would have 1/2 a subscript 0, or the original amount, which is equal to the original amount times e to the power of kt. So if we divide both sides by the original amount, it goes away, because dividing it by itself is going to have 1 on both sides. So now we have 1/2, which is equal to e to the kt. And then at this point, we can take the natural log of both sides. Taking the natural log of both sides, you have the natural log of 1/2, and what we end up with is kt. So now we have the natural log of 1 over 2. Now keep in mind here that what they're doing from this step to this step is taking the natural log of 1 minus the natural log of 2. Okay, so they're using the division property, and the natural log of 1 is 0, and 0 minus the natural log of 2 is negative natural log of 2, which is equal to kt. And then, in order to solve for t, we divide both sides by k. Now, since t, the time, is positive, k must, as expected, be negative. And this gives us the half-life formula, t, which is equal to the negative times the natural log of 2 divided by k.